Hello, and welcome to a special episode of Risky Business. Today, I'm going to be talking with Andrew Waterman and Yunsup Lee, who co-designed the RISC-V instruction set architecture. Andrew and Yunsup both received their PhDs from UC Berkeley, and they're the co-founders of SiFive. So today we're going to be discussing the following topics: Andrew and Yunsup's history before RISC-V, what led them to start on RISC-V, the history of RISC-V, where Andrew and Yunsup see RISC-V headed in the future, what kind of markets RISC-V might fit into, a bit about SiFive and the chips they are making, resources for learning about RISC-V and open hardware, and finally, ways to get involved in the RISC-V community. So, without further ado, let's begin the interview. So, my first question for both of you is, can you each give us a highlight reel of your life stories from before you began working on RISC-V?
Sure, I'll begin. So I'm 30 years old. I'm from New Orleans, Louisiana, and always was a technology aficionado when I was growing up, and decided sometime when I was in high school to become an electrical engineer. I went to Duke University and studied electrical and computer engineering and computer science, where kind of serendipitously I fell into computer architecture during my senior year of college. I was kind of listless and wasn't really sure what I was going to do with the rest of my life. But a professor there, Dan Soren, who teaches computer architecture at Duke, kind of kicked my ass a little bit and told me that I should go to grad school in computer architecture. So I applied a bunch of places, ended up loving the city of Berkeley and the people at the university, and so went there for grad school. And at Berkeley, I started working on simulators for multi-core architectures to accelerate other computer architecture research. And over the course of that project and some other projects that we were working on at the time, which Yunsup can elaborate on, we decided that we were not really happy with the idiosyncrasies of popular commercial instruction set architectures, and decided that we would make our own. And I think that segues into a question I expect you'll ask later. So before getting into that, I will let Yunsup answer this question.
Oh, sure. Yeah, I mean, I started out doing lots of programming when I was young, and eventually went into programming contests and things like that. But I was always kind of wondering what was underneath my abstraction level. So I started to keep digging and digging and digging until I hit computer architecture and transistors. And like I started wondering how to build those computers myself. So that kind of pursued, made myself come to Berkeley for grad school to learn how processors are built. And incidentally, Andrew and I started the same year at Berkeley in 2008. So the multiple simulator that Andrew mentioned about, we worked on that together. At some point, we looked at each other and we're like, we don't like what we're using right now. Why don't we go do something that we like? And that kind of became RISC-V.
Okay, awesome. Also, Yunsup, we lost your webcam. I don't know if.
Oh yeah, sorry. Our conference room has some Wi-Fi technical difficulties, and I was trying to cut some bandwidth down. Sorry,
Okay.
I couldn't hear your question, so.
That's fine. Okay, so that kind of what Andrew was ending on leads me to the next question, I guess, which is why did you guys decide to create a new ISA?
Right. So we've worked with several instruction sets before in our research efforts before starting RISC-V and before founding SiFive. And I think some great work went into those instruction set architectures, but there's this tendency for commercial computer architectures to grow over time, and they end up with a bit of feature and mission creep, which makes them difficult to use in research projects where you can conduct useful experiments without all of the complexities of such an ISA. And so we created RISC-V to have a simple basis for performing our research experimentation, and to ease the effort of teaching computer architecture in undergraduate courses at UC Berkeley. We expected, given that we aimed to design a relatively simple instruction set, that it would be a brief, maybe semester-long project to design the ISA. Of course, it ended up taking about 4 years to get the user ISA solidified. You may question our time management skills justifiably. But along the way, we learned something pretty important, which is that you don't need a lot of those features in order to design a high-performance instruction set architecture. Fundamentally, computers are pretty much just doing some loads and stores to memory, some arithmetic, and some comparisons. And control flow transfers. You have those. You have the majority of what happens when you compile a C code down to instructions. So a simple and elegant computer architecture can actually be pretty high performance. And so we decided to take RISC-V into a form where we hoped it would become an industrial standard as well as a utility for research and education.
To add a little bit on top of what Andrew just said, we were always, we always wanted to build actual processors, the physical thing. And we had about half a dozen people at Berkeley who were willing to do that together. And you look at existing commercial ISAs, I guess around 2010 when we started the RISC-V project, the viable options were ARM and x86, except that you can't really go implement those instruction sets with 6 people. So we had to go back to the roots of RISC argument that you don't need that many instructions and you don't need the complexity in the instruction set architecture. That kind of was one of the reasons why we started a new and simple instruction set.
Okay, and that leads right into my next question too, which is, well, I guess I'll skip one and go to this one, and then we'll go back to the one before. My question here is, what drew you specifically to RISC as opposed to a complex architecture?
Well, it was mostly because of I guess necessity. Because as a small team trying to build processors, you can't really start from a very complex instruction set. And as Andrew said, as we were going through our arguments and benchmarking things, we did realize, I guess, we figured out that the original arguments of the RISC, where you don't need that many instructions to build a high-performance computer.
Your audio just cut out, Yunsup.
Oh, yeah. Our Wi-Fi is... Can you hear me?
Yes.
Okay. Right. I mean, just to reiterate what I was trying to say is that we couldn't really go implement a complex instruction set with a small set of people. So it was really out of necessity that we had to do something different.
It's interesting. It follows the same pattern as the RISC-I and the RISC-II projects back at Berkeley in the early 1980s. At the time, quite a few people at Digital Equipment Corporation were surprised that a tiny team of academics were able to design and implement a microprocessor that was more performant than their VAX mini computer that they had dozens of engineers designing. And it would only have been possible if it were a simple instruction set architecture.
Right. So I guess the other question I have here is, what appealed to you about having it be open hardware? Like having everything be open?
Right, well, Yunsup, you can go ahead.
Sure. I mean, for me, when I started grad school, I was really eager to learn how processors are built. And I was sort of frustrated about the situation when in 2008 and 2010, where all the instruction sets are proprietary, and as you know, there are some documentation around, but there weren't really good designs that I can go take a look at and understand and learn. And that was kind of one of the reasons why, for me at least, that I thought RISC-V was cool, because we could, have RISC-V out in the open and also implementations as well, so that can also help people understand or learn who are willing to do so about processes.
Hey, Yunsup, your audio is a little bit inconsistent.
Yeah.
Okay. Andrew, why don't you answer the question while I go change computer system?
Right. So, I've always been encouraged by the competition of ideas in an open intellectual marketplace, and it's amazing to see what the open source software community has accomplished over the last several decades. I think for any good piece of proprietary software, there's almost always an open source competitor that's comparable to, if not more capable, and it's a bit disappointing that same pattern has not rapidly developed in the hardware industry, and I believe that we will end up in a place where people design better hardware at lower cost as a result of open hardware, and so that's why I think we want to be part of the leaders of that movement.
All right, that makes sense. So I guess really because of it being, I guess with it starting out as kind of being a research thing and an educational thing as well, that kind of ties into how, from your own experiences with learning about hardware and everything and trying to use it in that area, it makes sense that you'd want it to be open and something
That's
like
right.
RISC.
There's something very unappealing about using a proprietary technology to teach a course.
Right.
It doesn't make sense. It's like, it's comical by contrast to think of using the Windows kernel to teach an operating systems course.
Right. And Yunsup, are you back?
Is this better?
I can hear you.
Yeah, sounds good so far.
Okay, great. I got a bigger computer, which probably has better Wi-Fi. The problem is that my laptop isn't a RISC-V processor yet.
Yeah, exactly.
But the day will come, when Wi-Fi problems will be solved. Anyway, sorry about that.
That's fine. Did you have anything to add about what appealed about open hardware, or are you ready to go on to the next question?
I think Andrew covered most of the points I tried to make. Right now, the really appealing thing to me is that if RISC-V really takes off in the industry and is really used for many implementations or lots of applications or systems out there, for the first time, the thing that you learn in school would be actually the thing that industry uses. So that I think is the really cool part of the open aspect of RISC-V. That's what is really interesting to me.
Yeah, definitely. So looking to the future, what are you hoping to see happen in the world of RISC-V? I know that's kind of an open-ended question, but you can interpret that however you like.
Well, so first of all, I'm going to pair it with what the modest goal for the RISC-V Foundation is, which is to make RISC-V the standard instruction set architecture for all computing. So one of the this kind of ties into the question you asked earlier about why RISC, and a RISC ISA is suitable for the very low end of computing, as well as for the highest end of big iron, high performance computing, and so I think that while a lot of these more subversive technologies take root at the low end. In this case, I think that means embedded systems in the Internet of Things. I'm quite excited to see RISC-V take hold in domains like machine learning and eventually become a standard instruction set for for server architectures and for high performance computing as well.
That's very well put. I mean, I want to see RISC-V solve hard problems out in the field, and see a lot of RISC-V adoption in lots of different systems that people use.
Your audio cut out again, Yunsup.
Uh-oh. Can you hear me now?
Yes.
Yep.
Oh yeah, I mean, I was just trying to add on top of what Andrew said, that I want to see RISC-V go solve real hard problems out in the field.
Right.
I think with the end of Moore's law coming and the need for customization is rising, I think RISC-V can be a good medium where it can solve lots of problems there. Because, you know, you can grab the RISC-V instruction set, customize it for your needs, and that is all doable and encouraged within the RISC-V instruction set architecture. So.
Right, and that kind of answers a bit of my next question, which is naturally we'd all like to dream that someday RISC-V chips will be in anything and everything, right? But realistically speaking, do you think that's an attainable goal? And what markets do you think RISC-V is most likely to thrive in?
So
Yes.
I think it is an attainable goal over a long period of time. I think it may be that that RISC-V starts showing up in chips in a way that you don't quite expect. You know, there's a microprocessor in just about anything you buy today, and most of those microcontrollers use instruction sets that aren't really user facing. You know, so no one really knows that when you're buying a microwave, you know, you're buying a Z80 or something like that, that's controlling the LCD or something like that. So I think RISC-V will start showing up in a lot of places where people don't know it's there. But over time, I do expect that it will start being a more user-facing product in embedded systems that get programmed directly by engineers, and ultimately, hopefully, in mobile computers and laptops and so forth as well.
Anything?
Yeah, and I think also there are lots of new markets that are just showing up, and a lot of the people who are building systems in those new markets need new custom chips, and those people, I would guess, would be the first RISC-V adopters, because a lot of them are currently not well served by the current industry. And I think those people would be willing to look at alternatives to start with. And those people would be the people who would start using RISC-V. And I think, that will trickle into other parts of the industry. And one day we would wake up and it would just totally have flipped to, are you crazy to use RISC-V, to, are you crazy not to use RISC-V? It's just going to be that one day where it tips over and RISC-V becomes a norm. Like, why would you not do that?
Right. And these last few questions kind of tie into a question that one of my viewers has asked. Hossein says, my question is, considering the huge investments that are currently happening in custom chips for AI, how do you think SiFive can attract investors in the field of AI to pay more attention to your platform?
That's a great question. I think machine learning and AI are one of the new markets that are coming, and I believe those will be big. So in RISC-V, we've been working on the vector standard extension for SIMD type compute workloads, and machine learning and AI fits very well in that. The way that I see machine learning right now is that most of the players in machine learning are currently selling chips, which has fixed size SIMD engines. For example, GPUs are very, are widely used for training. But you look at those chips, and those chips are are very, very huge, but training is a big workload too, but you also need to do evaluation of your network too. And I really don't see some solution there which is customizable. So for example, if you have a network of a certain size, maybe the biggest chip is not the one that you want to use. I really don't see a custom solution for, like, for example, if you want to embed those type of workloads in your microcontrollers, you don't really see those type of products out there. And I think with RISC-V and the B standard extension and SiFive's capability to customize SOCs, I think we can well serve the upcoming market.
Yeah, to add on to that a little bit, I'd comment that evaluation of neural networks is going to be very frequently done in extremely energy constrained environments. So even if you have great microprocessor designs, great instruction set architectures, data parallelism, then it still may be too energy efficient to solve a problem. And so I think that that customization is going to be an important part of that. So RISC-V is part of the solution, but I think but making it easier to build custom chips is the other half of the equation.
Okay, so speaking of that, with you guys at SiFive, you kind of offer chips as a service. You guys are the co-founders, and you're the chief engineer and the CTO of SiFive, right? So can you tell us a bit about the company?
Yunsup, you want to lead off?
Sure. Yeah, so Andrew, myself, and Krista started SiFive, and our mission is to democratize access to custom silicon. So you see the traditional semiconductor market is really built around finding the billion-dollar sockets and make sure your organization is ready to scale up to serve that market. But as Moore's law is kind of grinding to a halt, that means that the need for customization in your chips are rising because of various reasons, because you need more performance or lower power or etc. But then, you see the flip side of the Moore's law argument is that the cost to build chips are also increasing exponentially. So it's kind of, we see that a lot of people in the market are kind of torn because the need for customization is going up, but the price is also going up. So lots of people who need to harness the power of custom silicon are being locked out of the market. And we thought that was also a big opportunity for SiFive. So basically, we're offering a customizable SoC platform as open source so that people can come and add their customization to their platform. And there is a one-stop shop to go build a custom silicon based off of our Freedom platforms.
So it dovetails really nicely with RISC-V as well. So one of the reasons that it's quite expensive to build custom chips with a commodity workflow these days is that licensing microprocessors is often a multi-million-dollar proposition. And so, reducing costs through an open ISA and an open hardware dovetails nicely with our goals to make it quite a bit cheaper to build custom chips.
Right. I remember I was talking with the viewer that asked the one question, Hossein. He works in like designing chips and stuff or whatever, and he was telling me about how like licensing ARM is like millions of dollars. So I definitely see how with RISC-V and like what you guys do at SiFive, how it really lowers the barrier of entry a lot for companies to go ahead and use a chip and customize it for their needs.
That's right. And I think that that's the reason that RISC-V is going to take off. Yunsup, Kirsten, and I, we all think ARM is a great company, and I think that if ARM is providing the thing that works right for you, then using ARM may well be the right thing to do. But for a lot of people, a lower cost option is the right thing.
Yeah, exactly. So then, moving topics to the Hi-Five One now. The Hi-Five One has been out for a little while now. Have you guys seen some cool projects? Like, what are the coolest projects that you've seen people doing with the boards?
Oh yeah, I mean, we've brought High Five One, the development board, to market last early December 2016, and so far we sold 1,000 boards, more than 1,000 boards, as a matter of fact, to 40 plus countries, which is really cool. People have been kind of tweeting, getting their boards, and you also kind of had an unboxing video, thank you, of the Hi-Fi One. That was cool. A lot of people have started to really play around with the Hi-Fi One board. I think one of the cool projects that I've seen people tweet after they got their Hi-Fi One board is to connect a printer to the Hi-Fi One board and running ADA to print, to talk to the printer. I thought that was really cool. A couple more things to talk about Hi-Fi One. I think the reason why open source and having an open source community is kind of cool is recently I've seen someone just write to the mailing list that they have successfully ported Zephyr OS to the Hi-Fi One board, and then they just put open source their Zephyr port on GitHub. I thought that was really cool. You know, a community, you know, building around RISC-V and the Hi-Fi One board. I think that's
you took the words right out of my mouth. I think it has been cool to to see people hook up Arduino shields, write some programs, print stuff to the LCD and all that. But I think that the community porting a real-time operating system, Zephyr, which is no minor task. Just for the hell of it, is really quite encouraging.
Yeah, that's really impressive that they've already ported an operating system. Okay, so what about Freedom Unleashed? Will SiFive be releasing any products with Freedom Unleashed chips, or is it purely for people who are looking to use the platform that you're offering, like the chips as a service?
Right. So one of the reasons why we built the Hi-Fi One board was that people can buy a low-cost development board which had the base platform already hardened into silicon, so that they can take the board and map their application on the board to benchmark the performance of the base platform. So obviously on the website we have shared our plans about the Freedom Everywhere platform as well as the Freedom Unleashed platform. So by induction, you can assume what we're really, working hard on. So, we think having a base platform of the Freedom Unleashed platform is very important, and I can share with you that we're working very, very hard to make that a reality right now.
Yeah, I'll just say that I am very excited to see a Unix capable RISC-V system come out sometime relatively soon.
Yeah, that'll be very exciting. So I guess my next question is, do you have any resources to recommend, either online or off, for learning about RISC-V or open hardware in general?
I'll first say that I'm a little bit biased here, but I think that reading the RISC-V user-level instruction set architecture manual is a great resource for learning about instruction set design in general. We took care, Kirsta especially, to carefully document the reasons we made decisions we did. So it's actually quite interesting to read. I think I'll preempt what I assume Yunsup is going to say. It's very exciting that there will be 2 textbooks coming out this year using RISC-V. Yunsup and I worked hard on a RISC-V edition of Patterson and Hennessy's influential undergraduate textbook, Computer Organization and Design. and professors Hennessy and Patterson themselves have been working on the new edition of the graduate textbook, Computer Architecture, A Quantitative Approach, which will also use RISC-V as the instruction set throughout the book.
So the undergraduate book is supposed to come out very soon, just ready for the fall semester. So stay tuned. And also, I'd like to also point out a couple additional things that we've been doing. So at Berkeley, there is a graduate level course building IoT chips. They've been using the Freedom platform as the basis of the SoC chip, the IoT SoC chips. So one of our engineers, the main engineers, Engineer Henry Cook, behind the Talent, the bus interconnect specification, has also gone and gave guest lectures and things like that, so that people can get ready to build their amazing things on top of the Freedom platforms. So I would suspect those activities will start happening even more at other universities as well, because we are very well committed to putting our work online, freely available to go build on top of.
All right, that's awesome. It sounds like there are quite a few good resources, both already available and coming for learning about this stuff. On this show.
And you know, even though you know, we're focusing on the commercialization of RISC-V microprocessors and the open hardware side of the equation now, I would like to you know, plug any university who's interested in using RISC-V. You know, we as we said earlier, we started the ISA design project to improve research and education at Berkeley. So it's wonderful to see more universities using RISC-V in the classroom.
Yeah, it sounds like it's the perfect fit for that type of use case. And I guess we're already down to my final question here, which is, what advice do you have for those looking to get involved in the RISC-V community?
Yunsup, you want to go first?
Yeah, I mean, I was just thinking, if you want to learn how computers work, I think RISC-V is a really good resource to go check out. There's, as Andrew said, the ISA manual has lots of rationale behind instruction set architecture. There's already, I think, more than a dozen open source implementations out there in order processors, out of order processors, and all that. So it's really good if you want to learn more about microprocessors. I think RISC-V is there. I just, you know, that message is, I guess, more for the people who want to learn about microprocessors. I think for people who are actually planning to build their products around a new SoC platform, I would really recommend go take a serious look at RISC-V, because if you're gonna invest time and resources, mainly, you know, money, I would think investing in RISC-V makes a lot of sense for the future, because a lot of people are committed to keep the RISC-V software ecosystem alive around the RISC-V standard. That means that the entire community is going to build around the RISC-V standard, ISA. That means that it will, whatever software out there will be kept up to date, and with the ability to go customize your own instruction set. So I think if you're really thinking about building a new product, I would really urge you to go take a look at the RISC-V ecosystem, because it's coming really, really quickly.
So there also, I'd like to add that there's a lot of work to be done still. There's work to be done on compilers, on operating systems, on the software side. I think there's room for innovation in microarchitecture. So get out there, go look at people's implementations, go look at the GCC compiler port. Just poke around and see what there is to improve, because boy, there's still a lot of work to be done.
Awesome. And I've got another question here from Hossein. He asks, is there any plan for massive online open courses?
I would, I can only guess. I would think yes. It makes a lot of sense.
Do you know if there's any plan to teach CS61C at Berkeley as an online course? I'm not actually sure.
Right, I'm not sure.
Yeah. So unfortunately, I'm certain the answer is yes, but I can't point to anything at this moment. Yeah.
All right. And one other thing that I'd like to point out as a good resource is the SiFive Forums. I've gone there a few times when I've had questions, and it's been very helpful. So I think that's a good resource for people too.
I'd like to shout out to our employee Megan Wachs, who is quite responsive on the forums.
Yeah, definitely. She's answered some of my questions. All right, and
any other questions?
That's all the questions I have. I wonder if the chat in the live stream has any more questions. Let's just give it a minute here and see if any more pop up.
Sure.
There's a little bit of lag on the live stream, so it takes a little bit.
Mm-hmm.
All right. Well, I'm not seeing any more questions, so I suppose that is everything. So thanks for talking with me today, you guys.
Thanks for having us, Nick.
Yeah, thanks for having us, Nick. Thanks a lot.
Yep. Oh, wait. There's one more question.
Oh, great.
Okay, Hossein asks, what is your answer to Linus Torvalds when he said ISA is not important and it's the community around ISA that matters?
That's a great question. I have given a talk several times presenting RISC-V where I make the claim that ISAs don't matter. So I agree with Linus in some respect that I think so. Linus is a bit focused on the high end market. Things like laptops and above. I guess I show my colors as an embedded systems person by calling a laptop high end. But in those domains, it's true that instruction sets don't really matter too much, and software is what matters. At the low end, however, instruction sets do matter. And when you're building really small microprocessors, the baggage of these commercial instruction sets becomes pretty significant. But either way, Hussein's question is apt. If you don't have a community around the system, then around an instruction set, then it will die. It will not be vibrant. So yeah, I think Linus is spot on, but I think that there's a little bit more to it than that.
My reaction to that is then why why not RISC-V then? Why don't you use RISC-V if instruction sets don't matter?
Yep, if instruction sets don't matter, you may as well pick an open one.
Exactly. That's my point.
Yeah, definitely.
So let's go build a software ecosystem together so that, there's no other excuses.
Yep, and it takes a village. So it's so please, if you have resources to help port software to RISC-V, pitch in. It'll be great.
All right. Do you guys have time for one more question? There's one more that popped up in the chat.
Sure.
Okay. Miblo asks that he missed the start of the stream, but he was wondering, do you personally have anything you'd like to see RISC-V users do that isn't necessarily endorsed or endorsable by SiFive?
Right. So, as we've said before, it's RISC-V is open. The instruction set designs in the public domain, and I think anyone can feel free to do anything they want with the ISA, and I think that that over time will result in better implementations and better software and so forth. So, I think. If you're interested in using RISC-V as a vehicle to learn about something like compiler technology, then go take one of those simple small compilers and port it to RISC-V or something like that. I think the more implementations of the instruction set, either in the form of Verilog RTL implementations or discrete 7400 series parts or Minecraft or whatever, the more implementations there are, the more software running on RISC-V, I think the better the project will be for everyone.
And anything to add to that, Yunsup?
I think Andrew put it well. Obviously, the benefits of the free and open instruction set is that it gets stronger as more people take a look at it and use it. I mean, I just want to point out the well-known software, open source software project, Linux, how it started out, and how people started out dismissing it right away. But then as time went by, many people pitched in, lots of companies pitched in. Now it's kind of the standard thing or the de facto thing that people would assume that they would use. And I think RISC-V is going to. It's been about 6-7 years since we started, so it's just the early stages of it. So if you have any kind of concerns or things like that, we need you to help out, to go build a great ecosystem out there. And as we work together, it's going to get stronger and stronger. So we really need your help.
All right, and that's the last question in the chat, so I guess that's the end for real now. So once again, thank you so much for having this chat today.
Thanks, Nick. It was a pleasure.
Thanks, Nick, and everyone else on the live stream. Have a great day today.
All right, and I'll just close by saying, stay risky, everyone.
Yes, indeed. Stay risky.
All right. Thank you, Nick.
Yep.
Have a good one.
Yep.
All right. Bye-bye.
Bye.